Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're jumping into our 3.14 notes. This will be the first of a few videos where we're starting to talk about what's known as the polar coordinate system. So generally when we deal with coordinates, we deal with the Cartesian plane. That's an XY plane where we had the X and Y axis. And we knew it was really just a grid, right? You go left and right, you go up and down. And that's all it really was. But now what we're looking at is polar. Polar means that you have poles. And if you think about this kind of like the Earth, where it's not a flat system now, right? You have to think about your longitude and your latitude, and it gives us a different type of coordinate system. This one is similar to polar. Polar uses distances and directions to specify the location of a point in the plane. To set up this system, we choose a fixed point called the pole. Same idea as the origin, right? Think about on the Earth, the North and South Pole. And from there, there's these little circles that go around it, right? You can see what this coordinate system looks like down below. Instead of it being grid lines, it's now an angle. It's how far do you rotate in a circle, and each of those circles are spaced out by one unit, which is known as the radius. There's different ways you can graph these points. Generally, I use one method just because I like to be consistent and not make any mistakes that way. So let's look at how to plot some of these points. When I look at this first one, it's A. Well, A is plotted at 2 comma pi over 6. Whenever you have these coordinates, it's always r, the radius, comma theta, the angle in which you're rotating. So what we're going to do is go out to where the radius is 2, which is right over here. And then we're going to rotate pi 6 from that spot. So we go from here, we rotate pi 6, and we know that coordinate A is just right here then. Same idea with B. You can go to where 4 is, and then you can rotate it along that circle, creating an angle of 5 pi 6. Here would be coordinate B. Same idea with some of these other ones. Go to 3, go to negative pi halves. Remember, that means you just rotate pi halves in the negative direction. That would be clockwise. So go to 3, rotate backwards. Pi halves are 90 degrees, and so forth. Okay, that's the idea of plotting using polar coordinates. Well, let's look at maybe applying some transformation, applying some rotation to a coordinate that's already on the polar plane. So I can go to 5, 1, 2, 3, 4, 5, rotate 4 pi thirds. That would be over here. Double check my distance, 1, 2, 3, 4, 5. Okay. So we have that set up. This is our coordinate P. But what we're doing is we're rotating clockwise. Okay, clockwise is this direction, pi halves. But when we do that rotation, realize what's going to change and what might not. Well, we know that the radius is 5. That 5 stays the same. The only thing that can change is the 4 pi thirds then, the angle that we rotate. But what does it change to? Well, we were at 4 pi thirds. We're rotating clockwise. Realize clockwise means I'm rotating backwards from where I started. So I would subtract pi halves with that. From there, you can go ahead and create your common denominators so that you can actually subtract. I should probably actually create those denominators. So 8 pi over 6 minus would be 3 pi over 6. So, okay, we have our common denominators. Combine them. 8 minus 3 gives us 5 pi 6. So what we did is we had this coordinate P. We rotated now backwards to figure out what we end at. Here's the rotation to right here, where this is now the image. I'm going to call it P prime. Okay, get that out of the way. I'll call this P prime up here too. And there you go. That's the idea of how we can apply a transformation. Realize if you're rotating clockwise, you would subtract because you're going backwards. But if you're going counterclockwise, you could take the angle and add with it whatever that rotation is. So on this next example, you would see that we're adding pi halves or 2 pi fourths to find the new angle at that specific spot. Okay, so there's just a basic idea so far. But sometimes things can get a little bit weirder when you go through this process. For example, if you start to have a negative radius instead, two ways you can deal with that. Both are kind of laid out in front of you. The first method is treat it like a positive, and then flip it to where it should be instead. For example, we go to 2 comma pi 6, which would be right here. And then we're going to flip it along this line here. Where, okay, it's going to be on the other side of the pole now, where instead of being at 2 units to the right, it's going to be 2 units to the left instead. So go to the pole, go backwards 2, and here would be that coordinate. Versus this one that was positive 2 and pi 6. The second method then says start at negative 2 on the unit circle. Well, negative 2 would just mean instead of going to the right, I'm going to the left 2 units. So here would be 2 comma 0, or sorry, negative 2 comma 0. And then from there, we can go ahead and rotate counterclockwise, right? We can apply pi 6. Well, pi 6 is going 30 degrees, so all I'm going to do then is just rotate it to this first spot. And now we're at negative 2 comma pi 6. Let's look at another example or two with that. Personally, I like the second method. I like applying the radius first. In this case, I have a radius of negative 4. So here is negative 4 comma 0. We're going to rotate around it 11 pi 6. Well, if you remember the unit circle, 11 pi 6 is pi 6 less than a full circle. So I'm going to go almost a full circle around this, tracing the circle, and we need to end wherever 11 pi 6 would be. That would be right here. And that's how this process works. You could then do that with some of these other examples as well. You could go negative 3. Let's look at C now. 1, 2, 3 in the negative direction. Rotate pi thirds. Well, this would be pi 6. This would then be pi thirds. So we're rotating it over here. Again, you got to have that unit circle mastered to really understand these rotations. Lastly, then, looking at this last problem, it says identify the point using both a positive and negative directed distance. I'm only going to do this for one of them and let you guys handle the others. So I'm just going to go ahead and do it for this frowning or angry face. Well, one way I might do is just count what line are they on, because that's the radius. That's one's quick to find. So 1, 2, 3. That one looks like it's on the 4th. So we want to talk about that with both a positive and a negative value as the radius. So 4 comma something and negative 4 comma something. Now let's just figure out the angles. Well, if we start at a radius of 4, how much do we have to rotate to get over here? Well, realize that's at the pi thirds position. And it looks like to me we're in the second quadrant, so that'd be 2 pi thirds. That's one way you might do this. Again, there's an infinite amount of combinations for this because it's a full circle. You could rotate a full 2 pi to come up with another sufficient answer. Okay, but let's think about the negative 4 now as well. So I'm going to change this one to be blue. Well, in order to have negative 4, let's go to where that would be. 1, 2, 3, 4 in the negative direction. Two ways you could do this. You could rotate all the way around the circle, or you could just go backwards. Either way would work. Again, we know we're at the pi thirds spot, If I go backwards, my angle would be negative, and I only had to go back a singular pi thirds. That's one option if you go the shorter way around. But if we want to go that other direction, the forward direction to get there, we know it's still pi thirds, but we did 1 pi third, 2 pi thirds, 3 pi thirds, 4 pi thirds. That looks like that would now be 4 pi thirds. Realize another way you might think about that is we did almost a full circle. So we know that it does need to be, I counted that wrong. That'd be 5. 1, 2, 3, 4. This would be the fifth one. Realize we almost did a full circle. We did pi thirds less than a full circle, so we know it'd be 5 pi thirds based off the unit circle there. There's our video breaking us into polar coordinates and everything. Come back next time for some more polar coordinates and getting into the polar system. Thanks for watching.